Again, in this lesson, we're going to introduce the concept of a relative minima or a relative maxima. The key word here is the word relative. So a relative minimum or minima occurs basically when it's the lowest point. So there's a lot of like fancy math, notation going on here. But what it's saying is if that point is lower than everything else around it. So notice here, this would be a relative minimum because this point is lower than everything in nearby. Okay, that would be a relative minimum. This point over here, the y value, again, we're talking about y, which they're calling f of a. Notice that this point is higher than everything nearby it. Now, over here, this is getting higher than this point, but that doesn't matter because it's relative. It's relative to what's around it. It's the highest point. So that's what it means when we say relative minima or maxima. So looking at this graph, I can see that I have a point that is lower than all of the other points around it, and I have a point that is higher than all of the other points around it, and then to the left it just goes on forever upward, and to the right it goes on forever downward. Those aren't going to be relative minima or maxima because they don't ever end. But if I'm looking for a relative minimum, that would be at x equals -2. The function has a relative minimum of -1. So the minimum is -1, which is of course the y value, but it's at x equals -2. The relative maximum, remember this is the point that is higher than the points in the nearby area, in this neighborhood, we'll say. So at x equals 0, the function has a maximum of +1 because it's higher than everything around it. Here's one for you to try, so press pause, try this question, then press play to check your work. In this question, it appears that I have a point, and we'll just pretend it's right on that line. We have a point right here, and we have a point right here. So we've got 3 different values, and notice I've already sort of separated it out over here that we have 2 minimums and a maximum. So looking at this one, I see that it's lower than everything around it. So at x equals -1, we have a minimum of -2. So it's a relative minimum because it's smaller relative to everything around it. At x equals 2, we have a maximum, a relative maximum of 3. So at x equals 2, we have a relative max of 3 because it's higher than everything around it. And then at x equals 4, we have a relative minimum of 0 because it's smaller, lower than everything around it.